Hey, Algebra 2, welcome to lesson 6.5. We're going to be talking about properties of logarithms today. It's going to be amazing. Our essential question today is, how are properties of logarithms used to simplify expressions and solve logarithmic equations? So first thing we need to do is introduce some of these properties of logarithms for you. Some notes to take for sure. And we'll get examples of each one of these things. So we have a product property, a quotient property, and a power property. So I'm going to go ahead and write some stuff down. So for the product property, right, if I had some, that's good. We'll just leave it like that. We'll do some examples here in just a moment. All right, so let's go ahead and put these properties right into use immediately, starting with some examples. Boom. So we can use these properties to expand logarithms, and we can use them to condense logarithms. We're going to go ahead and expand this one. So I'm going to use the property that if I have some So I'm going to use the property that says that if I have some log base whatever of x times y, that's equal to log of x plus log of y. So let's do that to this one. The other property we're going to use that if I have some log of x to the n power, I would write that as n to the log of x. So I'm going to use both properties. I'm going to do the first one first and the second one second. So here we go. Log base 5 of a squared plus log base 5 of b to the 7. I guess we could like it right on that. Okay. Now, now I'm going to do, so I use this property. Now I'm going to use this property that tells me basically that I can take this exponent and pull it out to the front. And I can take this one and pull it out to the front. So I'll write this as 2 log base 5 of a plus 7 log base 5 of b. And that's it. I can't do anything more to simplify it. Done. All right, let's check out another example. Here we go. So this one, I'm going to use the quotient property. So that tells me that if I have some log base whatever of a over b, I can write that as log of a minus log of b. Be careful, right? Remember that the top one goes first. It's important, right? We're talking subtraction. Order matters. Okay, order matters here. So I would write this then as natural log of 25 minus natural log of 3, and that's it. I like this one over here in the try it. So the first thing I need to do, because it's got a lot going on, right? So this one is going to be equal to log base 7 of, so first thing I'm going to do is use that quotient property. So this is going to be r cubed t to the 4th minus log base 7 of v. Okay? The next thing I need to do is I have a product here, right? So that is going to be equal to log base 7 of r cubed plus log base 7 of t to the fourth, right? I split this product up right here. And I'm going to leave this log base 7 of v out here on the end. The next thing I need to do is use that property that tells me that I can pull those exponents out to the front, and then I'll be done. So, right, this one's going to come out to the front, this one's going to come out to the front, so 3 log base 7 of r plus 4 log, ooh, I forgot the 7 here, shucks, log base 7 of t minus log base 7 of b, and we're done. All right, the next thing we're going to talk about is we're going to be, oh, should we try this on? Let's see. So now we're going to go ahead and take expanded logarithms and condense them or write them as one single logarithm. So we're going backwards, right? We're going to use these properties backwards. So the first thing I need to do is if I see a number out front like I do here, I'm going to go ahead and put it as an exponent. Okay? First step. So I'll write this as log base 4 of m to the fourth power. See, that 4 went into the logarithm. And I'll write this as log base 4 of n to the third power minus log base 4 of p. Now I'm going to use my product rule. Okay, product rule coming up first. So I'll write this as log base 4 of m to the fourth n cubed minus log base 4 of p. And now I'll use the quotient rule. It tells me that I can write this as log base 4 of, right? This guy goes in my numerator, this guy goes in my denominator, m to the fourth n cubed divided by p. Let's do another one. Here we go. Interesting that we started with a more challenging one. This one's not so bad. First of all, again, remember, if I've got a number out, the first thing I got to do is put this inside, okay? Got to put it inside. So I'm going to write this as natural log of 2 cubed minus natural log of 5 squared. Now I'll use my quotient property to write this as natural log of 2 cubed divided by 5 squared. I don't know, I'm curious to simplify it. This is 8 over 25. And that's it. All right, so the last one we're going to do is we're going to apply this to a real world problem because that's how we always do it, right? So let's go ahead and see what is the concentration of hydrogen ions in the acid rainfall. So pH of a solution, so acid rainfall, let's look at it. Acid rain, we got a pH of 4.5. Okay? pH of 4.5. So we're going to have to solve for H plus, right? That's our hydrogen ions. So I need to solve 4.5 equals log base 10 of 1 over the absolute value of this H plus, okay? All right. So the first thing I need to do is write it as 2 logarithms. So I'll write this as log base 10 of 1 minus log base 10 of the absolute value of H plus, okay? 10 to what power is 1? Thank you. 10 to the 0 power is 1, right? So log base 10 of 1 is 0. Okie dokie. Now I'm going to divide both sides by -1 just so that I wind up with a positive logarithm here. Just makes me feel better. Okay. Now we know how to solve this. I am going to write this as an exponential equation, right? So 10 to the -4.5 is equal to the absolute value of each point. Is it an absolute value? My bad. It's not an absolute value in the problem. Those are brackets, I guess? Sorry. Cool. I'm going to make them brackets. Sorry, these were brackets. Not absolute values. So there we go. Okay. And there we go. We've solved it. We used properties of logarithms to do it. It was awesome. Thank you guys for watching. I hope you're having a beautiful day. And if you're not, I really hope it gets better. Smile at somebody. Sometimes when they smile back, it makes you feel nice.